Swayam Prabha. Digital India. Educated India.
Let us take this example of this elbow flexion example, where I am carrying a load and lifting this load. So, I am lifting this load. So, the biceps, let us say this is the biceps. The biceps muscle has to actively contract for me to overcome the resisting moment and concentric action. So, in this case, the biceps for this particular action is called the agonist muscle. The intent tracks to perform the intended action is called the agonist muscle, and there may be more than one muscle doing that. So, they would all be agonists for that particular movement. Okay. So, it is possible that in this case, depending on the load that is being lifted, the biceps, you may also have two more muscles, the brachialis and the brachioradialis, which are also muscles that are elbow flexors. They may also be recruited to perform that, in which case those are also agonists. Now, the antagonist, so agonists are the muscles creating the same joint movement. The antagonists these are the muscles that are opposing or producing the opposite the muscles that are the elbow flexors are my agonists, and the muscles that are responsible for extension of the elbow are the antagonists for this particular action. Sorry? They may or may not be. They may or may not be. No, not necessarily, because you can, even when it is lengthened, you can, if you go back to the length tension curve, even when it is lengthening, you could have active to even in the lengthened form. Let me give you an example. If you are walking downhill, okay, so your knees, you know, when you are walking downhill, gravity is making you come down fast. Okay. Now, you have to control your knee. Okay. Your knee may be bent. The knee extensors may be in length, may be elongated, may be lengthened, but they will still be contracting to prevent you from falling. Okay. So, that is an example where in the lengthened condition you still have active muscle action happening. Okay. So, there that is your agonist muscle, even though it is in the lengthened form. Similarly, here another example with the same elbow. If I am carrying a heavy load, okay, and I start lowering it, okay, to what controls the speed? It is still my flexors, but they are lengthening, and I am still You'll be able to see the bulge, right? If you have carrying a heavy, you know that the muscle is also acting, it is also contracting to control this movement. Okay. So, in this case the biceps are again the agonist muscle, even though it is being lengthened, because the load that is actually causing this, working against this is gravity. Okay. It is not necessarily the, if I use my triceps to extend my elbow, then the triceps are the agonist and the biceps would be the antagonist. But if I am not, triceps are actually still the agonist muscle for this particular task. Okay. So, it is very task based, it is not that some muscles are always agonists, some muscles are always antagonists. Like I said, if I actively extend the knee, the quadriceps muscle acts to actively extend the knee, then again my quadriceps muscle is my agonist, and the hamstrings which are resisting that or dead are the antagonist. Okay. If I am flexing my leg like this, okay, then contract my hamstrings to flex my knee. I have to contract my hamstrings to flex my knee. So, there the hamstrings are the agonists because I am voluntarily flexing. So, the hamstrings are the agonists. In that case the quadriceps are my antagonists. So, the same set of muscles can function as agonists or antagonists. It really depends on the task. Okay. Flex my I could contract my triceps also, right, when I do that, provide additional resistance, I could do that because these are all voluntary. Muscle, the skeletal muscle can be controlled voluntarily. So, I could contract it. Okay. When you are in therapy or for exercise, they will teach you to kind of isolate your actions, so that you work hardest on the muscle that you want to build strength in. So, they will say no, relax your other muscle, because typically when you are tense, what happens? You try to contract everything that is possible. Okay. So, they will say no, relax this one, do only this, do only, if you are doing an elbow flexion exercise, say relax your triceps. Depends on the objective of the exercise. If you are trying to strengthen your elbow flexors, for instance, you want to focus all your, when we do the static analysis later, you will see that if I am also extending, if I am also using my triceps, then I would actually be loading my joints more, okay, which may not be desirable. Okay. So, I want to only load it to the extent that is necessary. So, if I am using both muscles on both sides to tighten and exert tension, then I would be loading the joint more. So, it may be more favorable to only use one muscle action to perform a particular task. Okay. So, then you also have muscles that are called the, and this is usually in your stabilizing effect on the in that complex to allow your arm or leg to do what you want it to do. Okay. So, these are muscles that really do not move very much, okay. The muscles in the chest and the shoulder, or not the shoulder, but in the back and the chest, which kind of hold things in place. So, that is why they are called the stabilizer muscles. Similarly, you have in the pelvis, as you are walking, to maintain the step, because everything is, it is all bunch of interconnected links. So, to hold the pelvis stable, while you make movements with your leg, like for instance when you are walking, you will have muscles that act only to do that. They are called stabilizer muscles. So, in a muscle, and they typically undergo very little movement. So, stabilizers specific movement in an adjacent joint occur. Okay. It is like keeping one thing fixed so that you can move the other the way you want it. Okay. So, these are muscles that undergo minimal movement. Then the fourth kind are what are known as the synergists or the neutralizers. And the function of these, as the name suggests, neutralizer, is to eliminate an undesired joint action. So, is a muscle that contracts to eliminate an undesired So, if you contract your gluteus maximus, okay, in the back, then you can produce thigh extension. It's an extensor, hip extensor. Gluteus maximus is one of your hip extensors, but the way it acts, it also tends to rotate the thigh externally. Now, if that external rotation of the thigh is unwanted, then a couple other muscles contract to internally rotate that, so that only your extension is left. Okay. So, that is the purpose of a neutralizer muscle. So, if the external rotation is undesired, then you have other muscles that similarly in the arms also, sometimes when you flex your arm, okay, then it may be accompanied by a supination action. So, the pronator may also act along with it to prevent that if you do not want that particular action. We do not think about these things so much, right, but that is what is happening. The muscles are working synergistically to ensure that the desired movement is what is performed. Okay. Yes?
So, in that case, let us say with a stabilizer or a neutralizer,
yeah,
do we really control it, or is it an indirect control, or it looks like it is more of a feedback, right? Let us say the antagonist is going to act.
you will have to really look at the neuroscience of it to see, we are not getting into the control aspects of the musculoskeletal system here, but in many cases we are, so I can decide that I want to do this, I can flex my elbow like this or like this, but I am making a conscious decision to flex it in a particular way. the muscles work with the neural system to ensure that things are activated such that my desired action happens. Okay. But I think if you maybe look at do the course on neuroscience of human movement, you might get the more detailed answers to these questions. And I am sure there are also areas of active research, because there is still a lot we do not know about how these things work. Even the models, they are all approximate, and they are all areas of very active research. Even the muscle action, the passive tension, the Hill's muscle model, people are constantly tweaking it. People are constantly looking at how to understand the physiology of the muscle and how to understand how that translates into the actions that we see or that we think that we control. Okay. So, those are aspects of neuroscience. Okay. So, I think with this I will you have a pretty good idea now of what we have done so far is that we have looked at the bones, we have looked at the structure of the bones, we have looked at how the bones come together to form different kinds of joints, and we have looked at how muscles influence the motion about those joints, okay, how they control. Next we will start looking at specific areas of the body. We will start off with say the upper, the arm, and then we will start looking at doing some analysis to understand, okay, what are the sort of forces that are, or the torques that a muscle has to generate to perform a certain task. Okay. We will start looking at some static analysis first. Essentially, we will be applying the principles of mechanics to the structure of the human body. We